Hi, in this video I'll be explaining you about Mitsubishi Electric's alpha controllers. These are very small controllers. They call it as the tiny giants. These controllers can have maximum 28 IOs. It looks like this. You can put an optional module here. It has got 12 by 4 matrix of LCD display, and you have got 8 keys. You can program using these 8 keys, or you can also program it with a Windows based software called as ALPCSWin, which is very user friendly. You need not be an expert to program these controllers. Just a basic knowledge of function blocks, logic gates is sufficient. So as you see, you can see an integrated HMI. You can use this either to program it, or you can also use it as a HMI to display the parameters from the controller or external IOs. In these controllers you can use 200 function blocks, and each function blocks you can repeat as many times as possible. And you can use this function block, join the wires, and you can try to create a simple logic to complex logic. It is really a very good controller. Complex tasks also can be achieved with this, but with the limited IOs. There are 6 basic models. It's basically the base unit. You've got AL2 10MRD, which is 10 IOs, that is 6 input and 4 output DC supply. And there is 10MRA, which is AC supply. Similarly, 14 IOs with DC and 14 IOs with AC, 24 IOs with DC and 24 IOs with AC. The outputs are relay outputs, and you can expand it with 4 digital inputs, or 4 digital inputs with AC option, or 4 digital outputs transistor type or relay type, or you can have 2 analog outputs. You can have analog to digital, that is for the PT100 sensors or thermocouples. You can have an analog input module. Basically the software is, these are accessories. The software is ALPCSWin. The cable which you use for programming is AL232 cab. This is basically an RS232 cable. You need to have a USB to serial converter to use it. And there is GSM cable in case you want to have a communication to send short message services using a SIM. And there are some frames if you want to fix it on the faceplate. So it's quite a good controller with moderate options. Now we look into how to program it. It will be a brief explanation. So this is the software. The version what we are using now is 2.7. That is the latest one available. Okay, so you need to create a new file. Here AL is actually the old series and AL2 is the new series. You select AL2. This is your basic controller. Okay, or I can say it as a main base unit. You can have either 10 IOs, 14 IOs, or 24 IOs. So let me just go with a smallest one, 6 IOs, 10 IOs, that is 6 inputs and 4 outputs. This 10 IOs cannot be expanded. So the moment you select 14 IOs, this expansion gets active, expansion area gets active. If you select 10 IOs, the expansion area doesn't get active. So you need to have at least 14 IOs to be expandable by 4 inputs or 4 outputs, or analog IOs. Okay, so let me just go with the 10 IOs to explain about the programming. So we have got this window. I'll just increase the working space on the window. This is actually the working area. So these are basically your inputs. In the DC model, these inputs can be used as an analog input as well. but voltage only, 0 to 10 volts. Now here you have got a pellet, which is basically having a toolbars. This is input toolbar. Here you can select for DC input, you can select this. For AC input, you can select this. Okay, if you have you want to convert this particular input in a DC model as 0 to 10 volts, then you need to select this here. See, when you select this, automatically a green dot comes. Okay, I will show you what happens when you wire it also. When you draw a wire, it will become a thick wire here. Okay, so let me just leave it as is, and this is output palette here. You can just use, it is basically a graphical representation only. You can use any of this, but the function will be just like a switch, that's all. So let me just select this one. Okay, let me go for this. Okay, so now we have got functions here and logic functions. So you can use these functions and logic functions put together on this workspace, connect them using wires. This is basically the wiring tool, and you can develop your own logic. So just let me make a small logic for a timer. Okay, so let me go to the functions. Let me use a delay timer here. So this is basically a function. By double clicking this function, I will get a palette or a dialog box where I can do the setting for this particular function. So I can take the time unit. I can use, by default it is 100 milliseconds. I can take it as 1 second or 10 milliseconds. Now in case I want a 10 seconds of delay, on delay, I will just put 10, and here I will use a second option. Okay, so let me just use 5. 10 is too much for this video. So this is a timer, on delay timer. For off delay, I need to use this, and I need to make this 0. So let me use an on delay timer now of 5 seconds. I use this wiring tool. I'll link this. Then wiring tool is activated. Okay, fine. Now we can simulate this. Go to the simulation, trigger it. So after 5 seconds, we see the output on. So this is a simple function which I have used. We have got plenty of good functions here, like pulse, set, reset, okay, one shot, up, down, counter, compare, flicker. Okay, you have got a time switch. In the time switch, you can define a certain time when your output should be on. You can use a calendar. Okay, you can use the dates when the output should be on, especially maybe for irrigation or for the greenhouse applications. So it's really a good controller. You can do a lot of complex tasks with this in simple, in few mouse clicks. You have got zone compare, gain, speed detects, pulse width modulation, many arithmetic applications. Okay, then you have got logic functions. For example, let me just remove this. I just put a digital input here. Let me just use a small digital function. So like an AND operation, I use a logic gate, use a wire here. So if I've got both my inputs on, only then my output should trigger on, should switch on. You can adjust the wires by just dragging it. So in this function, you see, it realizes the AND gate operation where all the input should be on for the output to be true. So You can do a lot of logics with this. So this is just a sample sample I've shown. Plus you can create user function blocks. That means if you have a program with say 2 inputs, 2 outputs, and you are going to repeat it for similar logic, you have a repetitive logic with the same amount of inputs and outputs, then what you can do is create a small logic within the user function block. Okay, create a small logic within the user function block. You have to define how many inputs and how many outputs. Then you can create a small program, and this program will be within, it will be something like a library function. So you can use this and it will have a logic within itself. And here is a display manager in case you want to program the display. You can say insert CDP, insert DP, and after that you can insert DP here, CDP, and insert DP. In this DP you can try to display certain functions, variables on the alpha controller, so it will act like an HMI. You can input the data, you can monitor the data. So in my future video I will be explaining much about this with the live controller. This is just for you to get a feeling about this. So this is all I would like to show in this video. In my future videos I will make something better, and with a live controller maybe you will realize much, you will understand much better with those videos. Thank you.